All right, so in this video, we're going to talk about power functions and polynomial functions. Specifically, we're going to learn to identify power functions, looking specifically at the end behavior of those power functions. In other words, what's going on with the function as x gets really, really large or really, really negative. I should say small, but it's negative. We're going to talk about polynomial functions and identify the degree and the leading coefficient of polynomial functions. So, power function is a function of the form f of x equals kx to the p. All right. Here, k is just a constant. Any constant, positive, negative, integer, fractional, whatever. Same thing with the power. The power can be positive or negative. Could be integer or fractional, whatever. So, and we have some examples of some power functions here, some of which you hopefully recognize, right? The one on the left here, we've got y equals x squared. And we know that, it's just plain old x squared because we've got 1, 1, we've got 2, 4, negative 1, 1, negative 2, 4. The next one over is y equals x cubed. So this is your cubic. And of course, the squared is not your quartic, it is your quadratic. So cubic y equals x cubed, and same story, we've got 1, 1, and we've got 2, 8, not that we see that on here. And these are just some examples. The next one over is 1 over x squared, which again, we have 1, 1, negative 1, 1. But all of our answers are positive there. All of our y values are positive. And then the last one is square root. Square root function, square root of x. But remember that square root is also the 1/2 power. And we can be pretty sure that it's square root because if we put in 4, we get out 2. Square root of 4 is 2. Okay, so is f of x equals x a power function? We already know it's a linear function, but the question is it also a power function? So we're going to rewrite it just a little bit. I'm going to put the 1 in there, 1x. And x is really x to the 1. And as soon as we see that, we can say, why, yes, it follows that pattern. We have a constant out front, and we have a constant power, and it's kx to the p. So yes, that one is a power function. What about 3 to the x? This one, the main requirement here is that it's x to a power, and this is 3 to the x, right? And there's a 1 there out front, but this one, no. This one is not following the power function, and it's not x to a power. It's 3 to an x power. So those rules are kind of reversed there. Okay. So we're going to talk about end behavior. So the end behavior of a graph is what the graph does as x goes to positive infinity or negative infinity. So we look at this. Of course, this is, again, y equals x squared. And we're asking, what is the function doing? What is f of x doing as x goes towards negative infinity? So this is x going to negative infinity. We're going off to the left. And we can see as we do that, our function is going up, right? So f of x is going to positive infinity. So we'll put positive infinity here. And then we're asking, hey, as x goes to positive infinity, let's put that in a different color. As we go off towards positive infinity in the x direction, what is the function doing? And we say, oh, look, it's going up. Also, it's going to keep going up and up and up. So it's going to positive infinity as well. So let's look at some graphs of power functions in GeoGebra. I'm going to pause this while I pull up GeoGebra. All right, so we're going to just graph y equals x to the p. And when we do this, GeoGebra is going to say, oh, I don't know what p is. Let's make it what's called a slider. Now, the slider, it's going to default to being from -5 to 5, and going by 0.1s, generally we can change that through the settings. So we're going to go to settings, and I'm going to change my slider. We're going to do it from -10 to 10, and I want that to have an increment of 1 because weird things happen with our power functions at other powers sometimes. Okay, so what this is going to let us do is say, okay, what's going to happen? Actually, I want it, let's focus on positive powers for right now. So let's make it just from 0 to 10. Okay, so when we take it to 0, of course, anything to the 0 power is 1. But if we go up to 1, we see we got a straight line, right? X to the 1. We take it up to 2, we get x squared, right? And we have that quadratic. We take it to 3, we see the cubic that we've seen a few times before, kind of that S shape. When we take it to 4, we see a parabola, but it's a little flatter at the bottom. And when I take it to 5, I see that S shape again, but it is a little flatter. Here we can put in y equals x cubed. You can see it's a little flatter than the x cubed right around close to that 0 power. And if you think about it, it makes sense, right? Because when you raise a number that's less than 1 to a power, you're going to be making it smaller. So what about if we go to 6? Again, we see the U shape, the parabola shape. Again, it gets a little bit flatter. 7, we see the S shape again, a little bit flatter in the middle. 8, U shape. 9, S shape. 10, x to the 10, we see the U shape. And we could even go all crazy. We could be like y equals x to the 200. What the heck, right? And you can see it is still technically a U shape, but it looks like really squared off corners there until you zoom in. All right. And if we made this the 201 power, what do you think is going to happen? That's right. You're going to get an S shape. I feel a little like Dora the Explorer there. So can we make a conjecture about the relationship between the power and the end behavior for positive integer values? And hopefully the answer is yes. There we go. Get back to this one. Hopefully the answer for that is yes. Oops. That if we have positive even powers on our quadratic, we're going to end up with end behavior that both are going in the same direction. Why do I have to say both going in the same direction instead of both going positive up to positive infinity? Because if that coefficient out front is negative, guess what happens? It's a reflection, and it would be that U shape would be reflected pointing downwards, and now we would be pointing downwards, right? If they are positive odd powers, then they're going to go in the opposite direction, right? As x goes, I'm going to put a little, actually, let's just make that a different color. So on one end, you're going to have one end of the function going down and one end of the function going up. And that's really all that there is to it. You can play with that slider and see what happens for negative values, what happens for integer or fractional values. So like if we go back and we go change that slider, let's go change it so that it can be -10 again. And you're going to kind of see same story, but we're not going to see that U shape. We're going to see, that like alternating kind of a saddle shape there. And so even negative powers, they're both going to be both in the positive. Odd powers, they're going to go kind of opposite corners, and you're going to kind of see that same, it's like you flip the S inside out and you flip the U inside out. It's really kind of what happened there. All right, so we're way over time. We're going to stop this one and go on to the next slide in the next video.